Let me ask you something. When you hear word robotics, what pops in your head? Terminator, giant factory robots, or endless lines of code from the Matrix? Yeah, I used to think that too. But here's the truth. Robotics is not for engineers. It's for anyone curious to ask. What if it could move? What if it could change life? What if it could solve real-world problems? That curiosity is where the robots began. Hi, I'm Karam. I'm the robotics trainer and researcher in Lab of Future. In Lab of Future, we don't teach robotics from a textbook. We use our streamer concept: science, technology, research, engineering, art, math, entrepreneurship, resilience, to make every project hands-on, meaningful, and future-driven. Our philosophy is very simple: think, build, test, and repeat. That's where resilience, creativity, and innovations come alive. Age 6 to 7, curiosity and exploration. At this stage, robotics is all about sparking curiosity. Projects include lab-controlled robot, simple obstacle-avoiding car, basic circuits with LED and motors. Outcome: children discover that their own ideas can come alive, igniting curiosity and building confidence. Age 8 to 10, real-world application. Here, students start seeing robotics as a tool to solve real-world problems. Projects include solar panel robotic arm, rockets models with sensor, VR-linked robotics for planetary exploration, telescopes and motorized planetary systems. Outcome: kids connect robotics with science, technology, and space, learning how engineering solves everyday and cosmic challenges. Age 11 to 14, entrepreneurship and innovation. At this stage, robotics shift from projects to solutions with purpose. Students design Arduino-based robot for climate monitoring, smart system for waste sort and assembly, home automation prototypes, real-time monitoring for temperature and gas sensor. Outcomes: students start thinking like entrepreneurs designing. Age 15 to 18, industry exposure and career readiness. By this stage, robotics become a gateway to industry. Capstone projects include autonomous navigation robots, robotics arm for manufacturing and space docking, computer vision and recognition systems, AI-powered robotics prototype. Outcomes: students gain exposure to industry practices, global competitions, and university-level research, preparing them for careers in AI, robotics, aerospace, and advanced engineering. Competitions and challenges. Our students showcase their work on national and global stages. First Lego League, VEX Robotics Competition, RoboCup Juniors and RoboCup Advanced, Bot Ball Robotics Program, NASA Robotics Challenge, RoboFest and World Robot Summit, National Robotics Challenges, International Science and Engineering Fair. From a school puzzle to global problem, and say, I can build something to solve this. Because here we don't just prepare students to use technology, we empower them to create it, shape it, and redefine the future with it.